This is example 5.2.3. It says determine the mass of an object on Earth if the weight is determined to be 500 newtons. So what we have here is we are given that the weight is 500 newtons, and it's asking us to find the mass. Now these questions are really common because a lot of people get mass and weight confused. They are different. Remember, mass is the same everywhere. So if I have a mass of m on Earth, it's going to be the same as it is on Mars. It's going to have the same mass value. Now what's different about it is going to be the gravitational force, because the gravitational force includes not only mass but gravity as well, where Fg equals mg. Now this g term is the gravitational field that the planet is on. Now since it tells me that it's on Earth, I can clearly say that g is equal to 9.8 meters per second squared. So remember, I'm trying to solve for, in this case, mass, and I can say Fg equals mg, divide both sides by g. Now this is confusing for a lot of people because they'll say, oh look, Fg divided by g, the g cancels out and I'm left with F equals m. That's not the case. Remember, this right here is a subscript letter. It's just defining what the force value is. Okay, so it's just saying that it is the gravitational force, but this whole thing is one variable. So now when you do this, you get m equals Fg divided by g, or in our case 500 divided by 9.8. When you do that, you should get an answer of about 50.2, I believe. Let's take a look at it. 500 divided by 9.8 gives you 51 kilograms. So let's check our units just to make sure that our units are correct. We have mass, which is measured in kilograms. We have force, which is measured in newtons. And we have gravity, which is measured in meters per second squared. At first glance, this doesn't seem to work out until you remember that the definition of a newton is a kilogram meter per second squared. When you remember that, meter per second squared cancels, leaving me with kilograms. So what I did algebraically does work.